this lecture, I want to talk about channel capacity. Chapter 7 of Carver and Thomas, second edition, or chapter 8 in the first edition, discusses the channel coding theory. The channel here is to mean a conditional probability distribution, P of Y output given X input. Given an input X belongs to an input alphabet X is fed to a channel, then we can talk about the range of outputs Y from the channel. What is the probability of an output Y given X? Answering this question for all X will define the channel. So basically, the conditional probability distribution. This input-output model is generally enough to accommodate many, if not all, input-output relations successfully. This you will see soon throughout the rest of the course. Given a channel, one can define the capacity of the channel. The capacity is the maximum amount of information that's per channel use that can be sent over the channel almost error-free. So this you will see in my note on chapter channel capacity. This is the most successful application of Shannon theory. Basically, the size of the message set that can be transmitted over the channel and be recovered almost error-free defines the channel capacity. The size is small for channel with loss of noise and distortion. The size will be larger for clean channel with no distortion. So these two statements basically tell you what the channel capacity could be. I mean, this gives you the qualitative statement. So more noise, small capacity. Less noise, larger capacity. So basically, this block diagram tells you the capacity of the channel or the channel configuration. So there is a physical channel, and you can send information over this physical channel. Then once you select a message from a message set, then you need to find a physical representation of your message, and this physical represented signal sent over the channel, and then at the receiver side, you receive this physical signal, and you map that signal to a message within the message set. That's how you detect the message. So what are the physical channels? Basically, statistical errors due to physical limitation can be introduced into the statistical channel. So physical channels can be represented as statistical channel. So what are such physical channels? So consider this. A digital symbol sent error transmitter versus a digital symbol decided at a receiver. So this transmitter and receiver is a pair. What was sent could be different from what was decided at the receiver. So in this discrepancy from symbol at the transmitter and symbol at the receiver, we may use the statistical error channel. Another example is the word prepared to utter inside your head versus the word actually spoken out. These two could be different with each other. So there is an input-output relation with certain noise or errors introduced between them. Another example is reading from a memory device. For example, magnetic recording tape, hard disks, memory cells, and so on. So you have some file that is on input. You want to store it into a memory device. So there is a discrepancy between the input file and what was actually stored in the memory device. So there are these two differences. I mean, the difference between the two files could be modeled as errors. And there is a channel exists between the input file and the output file, which is recorded in the memory cell. Another example is reading from a memory device. So I think I have switched writing and reading in my previous example. So my previous example was about writing. And then this example that I'm going to talk right now is the example that you read off from a memory device. So what is written inside the memory cell, and there is read file from the memory device. So before and after the reading was done, okay? So there is a discrepancy. There could be discrepancy between the two, and then there exists a channel. So channel is to model these discrepancies or errors or disturbances and so on. And this can be statistically modeled. Another thing is there is an input picture with a class level given as an input to a neural network classifier. And then classifier makes a decision, and then output is a classified label. So there is a input class label and the output class label. There exists a channel between them. So these are physical channels that we are talking about. But before I move on to further materials in chapter 7 of Carver and Thomas, I would like to use an example of a channel code. Basically, a channel code is to protect from the errors introduced by physical channels. And at the receiver, the errors can be self-corrected using a decoding algorithm. So at the transmitter, encoding is done in order to prepare the information that you sent over the physical channel in order to have the information sent over the physical channel protected from statistical errors introduced by the physical channel. And at the receiver, you can correct the errors using the encoding relation that was given at the transmitter. So in general, the transmitted word have some redundancies, some added information to the message bits that you sent to represent the message. These additional bits are going to give you protection against random errors introduced within the channel. So using this redundancy information, you can self-correct the transmitted word at the receiver. Okay, so having said that, I want to move on to the example of Hamming code.